All right, so we're looking at lesson set 18. I think it might be 19. I'm not sure. I'll check and then I'll upload this and hopefully put down the correct number for this lesson set, which is going to be mostly mechanical practice. Try to build some skill here and make sure I can center that so everybody can see. So I'm doing the C column of a worksheet we're working on in class. And so there are three problems, similar types, but I'm going to tackle the last one, the last column, because some of those are a little more difficult questions than letter A and letter B are. So let's have at it. I'm already making a change on the worksheet. We're not going to get till the unit circle here until after midterm. We've had missed some classes, snow days, missing school tomorrow. People are sick. So I'm holding off on that until after midterm, but we can certainly make some progress elsewhere. So I'll be replacing that on the test with point of inflection for a cubic, which is based on completing the cube. And if you look at that, the geometry behind it, maybe minus b over 3a will make some sense. Cubics are three-dimensional, and completing the cube, cubes have length, width, and height. And if you change the dimensions slightly, just slightly, the average of the roots will find you the x value of the point of inflection. So minus b 12 divided by 6 is 2. Plugging 2 in will get us our point of inflection. We already know 2 is the x. I have a formula here for finding y's, a calculation. So 2 cubed, let's do it right here. 2 cubed is 8 times 2 is 16. There's a 3-to-1 ratio, 3-to-1 ratio. It has a lot to do with surface area, three sides of the surface area of a perfect cube. And so when I put 2 in, I'm going to get 3 times this and the opposite. And if I don't get that relationship, then I have not picked the right x value. And 2 times 5 is 10. And 10 minus 10 is a lucky stroke of the marker. So as that can disappear, and it's always twice this and change the sign. So minus 32, there are some shortcuts to doing that evaluation, but that's the point of inflection. Now, if I was going to graph this cubic, doesn't hurt to hear this, I would have started on the y-axis at negative 10. And I would have been going up at 5-to-1. And at 2, I get negative 32, which is below negative 10. So I know I got a graph that looks something like that. Goes up forever on the right, down forever on the left. And at that location, 2, negative 32, I am going down fastest right here. Okay, I'm going to go down fastest, and then my slopes at every instant are increasing from that location. Okay, even though I'm going down, I'm not going down as quickly here, right, at that location. So we're going to be talking more and more about cubics in the second half. We're just getting the conversation started. So now we're trying to find the quadratic that has that as answers. Probably comes from completing the square. So now we're going to go backwards. Subtraction of 5. Remember, 0 is on the right. So everything over here has got to get moved over to there. The first thing I'll move is minus 5. So that's x plus 5. I don't remember if it was a minus on your sheet or if it was a plus. Okay, I might have miscopied that. But this is what we have in front of us. If it was positive 5, then it would have been a minus. So no big deal. Equals plus minus 7i. You know, I think that comes from plus minus square root of a negative. And it's probably 49. Okay, so how am I going to see that? I'm going to square both sides. X squared plus 10x plus 25 equals positive 49i squared. And that's negative 49. So that becomes x squared plus 10x, 50 and 25, 75. So I know that's 74. It's one less. And there's my answer. Now we want to get good at going from here back to here. We want to get good at that. So let's practice it right now. What am I going to do? I'm going to complete the square. X plus 5 squared minus 25 plus 74 equals 0. I'm going to take my positive 49 and move it to the other side. There's minus 49. X plus 5 squared equals minus 49. I'm going to set x plus 5 equal to plus minus the square root of negative 49, which is imaginary. So there's your 7i. Bring the 5 over. There's your negative 5. And I hope we get good at that. All right, next problem. Piecewise. Well, I know I got a V shape to the vertex, and the vertex is 6, 1, but I'm just going to write 6. And then I go up. All right, so what do we have? We have 2 branches. The first branch, remember what x minus 6 is. X minus 6 is a line that has an x-intercept at 6, and it has a sign change from negative to positive. What happens when I slap it with an absolute value? That's where it hinges. Okay, that sign change no longer exists. Those negative values are now y, those negative y values are now positive y values. I've done nothing to the x's, I'm just counting. But the outputs have changed from negative to positive. That's what this does. Okay, measures distance from 0 on the x-axis for x values. Okay, so therefore, one branch is going down at 4, x minus 6 plus 1. Now I need the 1. That's a location on a curve. But I'm only on the down branch. Let's get rid of the 1 again. For x's that are on this side. And those x's are less than 6. I'm going up at 4 to 1 for x's greater than or equal to 6. Now let's put a 0 in here. Gets me 25. So let's actually compute 0, 25 to 6, 1. Write the equation of the line. I hope you'd say x minus 6 plus 1. How do you get from 25 to 1? I think you're going down 25. What's your change in x from 0 to 6? I think you're going down 24, excuse me. How do you get from 0 to 6? You change by 6. Sure looks like the slope on this side. The slope on this side is negative 4. And they share the 0.61. Sort of. They don't share anymore based on what I wrote there. But I am taking care of the 0.61. It does exist. Put a 6 and a 1 in. 6 there, you get a 1. All right, I think I said enough. So that's piecewise function. That's on your test. ln of 25. Well, I've asked you to memorize that number. E to the what gets me 5. I didn't ask you to memorize 25. I asked you to memorize this one. And I hope you say 1.6. Maybe you'll remember it now that I mention it. So let's get this organically. 25 is 5 squared, which is equal to e to the 1, approximately. E to the 1.6 is approximately 5. And I'm squaring that. And I'm looking for the exponential activity on top of e. Can you see the exponential activity on top of e? Can you say maybe this is close to 3.2? That's actually a rule of logarithms. ln of 25 is the ln of 5 squared. We talked about that. And that's 2 times the ln of 5. That's a rule. Oh, I can see 2 times 1.6, which is the ln of 5. Huh. And that exponential activity right here, that exponential activity is generating 25. I'm not asking you the rules of logarithms yet, but might as well start the conversation because it's embedded in this problem. All right, now what would happen if I had x minus 5 squared over 9 plus y plus 1 squared over 9 equals 1? Well, I hope you get rid of the fractions and multiply everything by 9. And you'd have x minus 5 squared plus y plus 1 squared equals 9. And I think everybody in the room would recognize that as a circle centered at 5, negative 1, with a radius of 3. So how does this differ? Well, I've been asking you to find coordinates. All right, so let's find some coordinates. This is what's been on every test and worksheet. Some of you are looking at it for the first time because you know 2 weeks from now I'm grading you. Be nice if you worked consistently every night. All right, if I put in a 5, I'm going to get 2 responses from y. One of them is going to be 2, and one of them is going to be negative 3. Let's plot that. 5, 2. Let's call that 5, 2. And let's call this 5, negative 3. You see that? Barely. But I could have put negative 1 in for y. Hope you see why. And I could get 2 answers over here. One of them would be 7. 7 gets you negative 1. Where's 7? If this is 5, 7's here. Negative 1 is there. And also 3. 3 works. 3 might be here. And I'm starting to see this shape. That's an ellipse. Guess what the center is? 5, negative 1. That's 5, negative 1. How far is it from negative 1 to 2? 3 units up, 3 units down. And what's underneath the y values? 9. And how do we find the radius of a circle? We take that square root. Well, that's going to give us what's called the major axis. Because I'm only going 2 to the right and 2 to the left to get to places like 5, negative 1. I'm sorry, to get to 5, 2. 5, 2, well, that's that one. So to get from 5, negative 1, side to side, to get to 7, negative 1. So excuse me. How far is it from 5 to 7? 2 units. And what's the square root of 4? 2. Okay, so that's up and running. I'm going to only ask you to come up with coordinates that work. We haven't graphed these yet. It might be the first time I've gone over that with you. All right, so just some skill practice now. We've talked about these enough in the earlier lesson sets, so I'm not going to do anything except give you answers here. So I'm going to multiply this one by 70. 5, 2, and 7 are primes, so 10 times 7, 70 gets rid of the fractions. That's 14x. 35 times negative 3 minus 105. X, 7, 10, 50. Okay, so I'm going to bring that to the other side, and that's going to be 91x when I change the signs, negative 50, and I think I've got negative 50 over 91. I think that's my x value. All right, let's make some more room. Previous lesson sets, we've moved the negative exponents into the other locations. So numerator, I'm going to the denominator, changing the sign. I'm keeping my x, I'm keeping my y5 there. I'm keeping my 9 down here. I'm keeping my x squared. So that's the only thing I had to move. I only had to move that. Okay, so now what does this become? 9 times 9, I see 81 here. I see an x and an x squared. I see 1 more x there. I see y to the 5, y. I see 4 more there. Really, what you're doing is just counting. Okay. Y to the 5, 1, 2, 3, 4, 5. Y to the 1, one of them divides out. I get 4 left. That's what I'm doing. 40 was a bit of a word problem. Amount is a function of time. So what's my initial amount? 35 marbles. You don't have the word problem in front of you, but that's what it would be. 10 minutes. In 10 minutes, that thing, from the start of the experiment, 10 minutes later, it doubled. So I'm going to write x minus 10 so I can highlight the number 10. It doubles. And I said every 73 minutes. Okay, so I started with 35 miles. They double every 73 minutes. And I noticed the doubling occurred after 10 minutes. Put the number 10 in. 2 to the 0 is 1. You start with 35. Put 83 in. You get 1. You double 70, so on and so forth. Okay, 9x squared minus 1 equals 0. 2 ways to do that. 2 ways to do it. 9x squared minus 1 equals 0. 1, inverse operations. Answers 1 plus or minus a third. The other way would have been to see it as a difference of two squares. And then you got negative 1/3 and you got positive 1/3. All right, so hopefully you see that. Okay, just starting to work with radicals. They'll continue to get harder during the second half. I'm hoping you see square root of 4, square root of 5. I'm hoping you see 2, square root of 9, square root of 5. And I'm hoping you see 4 root 5. What does this become? 10 root 5 minus 6 root 5 plus 4 root 5. I think I'm counting root 5s. I think I have 10x minus 6x plus 4x if x was equal to the square root of 5. So what do I have? 10 minus 6 is 4 plus 4, 8 root 5. That's what I'm seeing. Now we're going to do a system of equations. It's easiest to do elimination. So I'm going to multiply the bottom by positive up by negative 3. So there's my top line. I got a line that's going down, and I got another one that's going down. Yeah, oh well. Where's the tricky point of intersection? Multiplying by negative 3 minus 21x, positive 3y. Hopefully you can see why I'm doing that. Positive 36. 36 minus 8, 28, divided by, looks like negative 19. So that's my first answer, negative 28/19. Okay, no friendly numbers. So now I got to go for the x's. Since I got to go for the x's, I'll multiply this one by 2 and this one by negative 7, and I hope you can see why. I'm not even going to look at the x column. I'm just going to do the y column. So minus 7 times minus 3 is 21y. 2 times minus y is minus 2y. And over here, I got minus 7 times minus 8, positive 56. And I've got 2 times minus 12, minus 24. And it looks like I have 19y equals, take 20 away from 56, 46, 36, take 4 more away, 32. And so my y value was 32 over 19. Real easy to make mistakes there. Forget a sign, add or subtract wrong, especially when you're doing so many problems. But that's that one. I got Yasser to back me up. If I make a mistake, Yasser, put it in the notes. All right, so yeah, I am asking g of x. I think it's important to see that because it really highlights whether or not you understand functional notation. What's another name for g of x? X squared plus 5. So I basically just did that part. And now I'm not doing x anymore. I'm doing g of x squared plus 5. Oop. Okay, so g of x is x squared plus 5, which means I'm taking things, squaring them, and adding 5. And if I put g of x in there, then I'm squaring it and adding 5. We've gotten good at binomial squaring. A lot of folks can do this well. X to the 4th. That product gets doubled, 10x squared. 25 and 5, 30. And that's g of x. Log. This has really been mentioned a few times, but I've never asked it on a worksheet, I don't think. I've done it in class. Okay, so what's missing here? The base. You don't see it. If you don't see it, it's meant to be the number 10. It's called a common log. It's a button on your calculator. Log x is on your calculator. And its inverse is on there, usually 2. 10 to the x. That's the inverse of that. Okay, but we don't write the base. So how do I solve this problem? Well, the inverse of logging base 10 is exponentiating base 10. I still have 2x over 3 on this side. So that's 30 divided by 2, 15. Okay, if I put 15 in, I get 30 divided by 3. 30 divided by 3 is 10. What's log 10? Especially if you don't see the base. Well, what do you put on top of a 10 to get a 10? A 1. So that's a common log. You'll see it again. All right, so this is one I did in the last lesson set, and I botched it because I think I I don't know, I got lost in the problem. I think, yeah, it was the 4 get you the 6, and then I got lost in the problem and I put 4 back into the inverse. I should have put 6. So what I did was right, and how I stated it was wrong. All right, so first thing we do is we change h of x to y, and we look at x minus 2 over x plus 3. To find an inverse, we switch the x's and the y's. And now we got to get our y's together. Well, we can multiply x times y plus 3 and set that to y minus 2. We can multiply this out. Xy plus 3x equals y minus 2. We can bring our y to the other side, xy minus y. We can take our x's to the other side, minus 2 minus 3x. Now I can factor out the y, and I get x minus 1 equals minus 2 minus 3x, and I'm having trouble bending down. So multiplication by x minus 1 becomes division of x minus 1, and that's an ugly inverse. That's the hardest one I'll ask you all term, probably. Maybe something in class, but on a test? Yeah, that's a challenging question for you. Okay, but switch the x's and the y's, solve for y, got to get the y's together. And writing it as a product, isolated it. So there we have it. I think I erased part of what I did there. Hopefully you're following. And if it went right over the head, well, just do the rest of the problems, come back to it tomorrow morning, look at it again, probably make more sense. All right, so we're looking at the roots. Uh-oh. Uh-oh. Don't tell me our lights just went out. Good. I do not know why that happened. Seems like somebody shut down the whole building here. All right, maybe they did. All right, so the first thing I see is my answers. Two answers here are imaginary. Okay, so I know I got imaginary because roots are y equals 0 and 0 is above -3, and this is not intersecting there. We can move it in the other direction using I squared. That's a sign changer. And a sign changer on a downward cup shape is an upward cup shape, and then we would have our intersections right there and there. All right, so what is going on here? Are you shutting the lights off the whole place? It's you. You're doing it to me. Oh, it's Gerard. You're going live now. This is on a YouTube channel. Yeah, I guess it does. All right, we solved it. We solved it. All right. He's a good buddy, so I can do that. Yeah, we got an adjacent room here. I guess we're connected with the electricity. So back up and running. That'll be the last time the lights go off. All right, you could have put this in graphing form. First off, you can just answer. So we're measuring from 8. We're moving to the right and to the left of 8. How far do we have to go up? 3 units. We're dividing by 2. Well, actually negative. So, we have to go up 3. We're dividing by -2. We're taking a square root. Hopefully you can see why I'm putting the I there. Now, you aren't seeing that. We could put this in graphing form. -2x minus 8 squared plus -3, equals 0. I hope you can see what we're doing here. Moving the 3, dividing by -2, taking a plus minus square root, right? And then adding 8. I kind of ran out of room. Okay, so that's practice for that one. All right. 16 is 2 to the 4. And I'm raising that to the x minus 1. I got to get the same base here. 4 is 2 squared to the 3x plus 1. Okay, the bases are the same, so the exponential activity has to be the same. So that's 4x minus 4 equals 6x plus 2. And I hope you can see why I have to distribute that, because this is some number. When I put x in, it's some number. When I put x in, it's some number, and I'm multiplying times 4, I got to multiply both parts. All right, we can do this in our heads now. Take x away from 3x, there's 2x. Move 1 over to the other side. Oh, I'm here, I'm sorry. Take the x's over there, that's 2x. Move the 2 to this side, -6. So -3. That's our answer. Day one, we started with problems like this. I hope you know what that means. I hope you know that that 4 means the fourth root of 16. And I hope you know the -1 means take a reciprocal. So that's equal to a half. Right? This minus sign has nothing to do with whether the quantity at the end is a plus or a minus. Nothing to do with that. It's just where's the numerical activity? Where's the exponential activity? The minus sign says in the denominator. All right. So the next problem is designed to see if you really understand mechanics and when you spot something that needs to be worked with, that you can do it. All right, so that's the exponent I put on top of x to get x plus 30. Well, this is a standalone problem. This is quadratics. So x squared minus x minus 30 equals 0. I can see the 6 and the 5. X minus 6, x plus 5. By definition, the bases of exponentials have to be positive. So I'm not going to worry about -5. My only answer is going to be x equals 6. Now, we haven't talked about, the restriction on the base a lot. It's been mentioned probably 4 or 5 times, but I don't think I've given it to you in a formal way like this. So if you write 5, -5, I'll probably give you a 3/4 credit. All right, so this is what we lectured on a couple of days ago. I don't like doing lectures, but I'm hoping people see. Let's see, can I do it over here instead? Because I have rotator cuff some issues. So subtraction of 1 becomes addition of 1. That's gone. Multiplication by 2 becomes division by 2. That's gone. E to the becomes ln of. E to the becomes ln the of. ln of becomes e to the. Okay, so now I got to multiply by 100. And I might as well look at ln of 4, which is 2 squared, right? E to the 0.7 squared is 2 squared, approximately. So that's about 1.4 if I want to get a decimal approximation. And then I've got adding 1905. So in the year 140, right, 2 decimal places, plus 1905 is 2045. If I was approximating in years, the exact answer is 100 ln of 4 plus 1905. I'll take either answer. All right, so now this is solving absolute value, so I can reach up now. I'm going to subtract 9, so that's 18. Divide by -3, that's -6. Absolute value, so that's plus minus 6. Right, I'm going to take the absolute value now. Okay, and now I can see what I'm plus minus 6. I've got to be careful because I missed the rate of change the last time I did this. So I'll just keep going. So I've got a positive 6 and a -6. Let's split it up. I've got 6 and -6. And then I'm going to add 2. Well, this one becomes 8. This one becomes -4. I'm going to divide by 2. This one becomes 4. This one becomes -2. Let's just check. One of the answers is 4. 8 minus 2, 6. That's the value of 6. 6 times -3. Looks like I made a mistake. Oh, I'm probably on the wrong branch. Because, yeah, I'm probably on the wrong branch here. All right, so let's plug in -2. -2 times 2 is, did I make a mistake here? 18, -6, that's right. Absolute value, positive 6, right? Plus minus. Okay. Oh boy, I fooled myself here. Just working mechanics. I never looked at it conceptually. So let's look at this graphically. I have a V shape down. Not going to do the video again. I got a V shape down, and it's centered at 1, 9. And I'm asking the question, when does that hit a height of 27? Well, there's no solution to that. And that's what was happening as I was just mechanically doing it, because I didn't think I'd ask that. I don't usually like trick questions. It's not really a trick question. It's a good question. And I fooled myself. Nothing new there. Okay, so no solution to this. So let's get one that has a solution for practice, because I'm not going to throw that at you on a test. unless it's in the middle of the term and you're really trying to get a grade right now. So let's just say that this is negative 27. And now let's solve. All right, subtract 9, so that's minus 36. Divide by negative 3 is positive 12. Absolute value, that's why I did stop there for a minute. When I took the absolute value of the negative, I don't know. So that's plus minus 12. Let's add, so let's break that up into 12 and make negative 12 now. Then let's add 2, so that's 14. Add 2, that's negative 10. And then the last thing is divide by 2, 7, negative 5. Okay, that's nice because if I add those up and divide by 2, I get 1, and that's the critical number here. So that's probably just fine, but let's put a 7 in. 14 minus 2, 12, negative 36 plus 9, negative 27. Okay, so that's how you solve. Typical absolute value problem. Inverse operations. When you get to the absolute value symbol, plus minus on the other side. Okay, a couple of different ways to do this. I think I'm going to simplify these first. So that's 2 root 4 root 3 minus 5 root 4 root 3. Wow. Interesting. Okay, so that's root 2 times 4 root 3 minus 10 root 3. I might as well subtract those. Root 2 times minus 6 root 3. And I think I can write that as minus 6 root 6. Okay, that's what it was. Let's look at this graphically first. The square root of x minus 2. X-axis, 2, 0. Positive square root, boom. X minus 4, here's your y-axis. Minus 4 is here, over 1, up 1. This is going to have me intersecting this only at one place. I'm going to have a fictitious answer that's going to be a couple of units bigger than 2 probably. Let's solve it. Let's square both sides. X minus 2 equals x squared minus 8x plus 16. You're going to have a lot of trouble if you can't binomial square. 0 equals x squared minus 9x plus 18. That's a 3 and a 6. 0 equals x minus 3. That was this one. That's where x equals 3 fictitious answer. So that's not going to work. X minus 6. That's this one. That's where they intersect. 6 minus 4 is 2. 6 minus 2 is 4, and the square root of 4 is 2. So it hit a height of 2 at that location, but we were only solving for the x value. That's what this equation was. Find the x. We found it. It's 6. But that's where those graphs intersect. All right, let's get rid of that. All right. X squared minus 25. How do you reduce fractions? You write differences and sums as products. So that's a difference of 2 squares, x plus 5y, x minus 5y. And in the denominator, I have 5y minus x. It's kind of like saying that backwards. So what's 6 minus 2? Let's say that was in the numerator. And in the denominator, I have 2 minus 6. Do the math. Yeah, these divide out to be the number -1. And -1 times x plus 5y is minus x minus 5y. That's your answer to that problem. Okay, we're getting there. Come on, Renee, don't go running off on me there. Now I know why Gerard was laughing. He was shutting the lights off and I was turning them on. I didn't know he was over there and he didn't know I was over here. Oh, that was funny. All right, so bingo, bango, bongo. I can do bongo real quick, 20. Bingo, 7x minus 4 times 4 is 28x minus 16. Plus sign, excuse me. I'm so used to doing the minus that I just automatically wrote a minus. And I wish I had written a minus or a plus because you're not going to get fooled on this one. 15x plus 10. I wish it was a minus because we're having trouble with the distribution there. So that was a poorly crafted problem on my part. And since it's a video, I'm gonna change it. I'm gonna make it a minus. There, changed problem. Now, what's our final answer? 28x minus 15x, 13x, minus 16 minus 10, minus 26 over 20. I can see a 2 gets me a 0. Is that going to help me anywhere? I can put a 2 in here, comes out as a 0. So if I put a 2 in here, 28 minus 4, 24 fifths. That's not going to be 0, is it? Plug in a 2, 8 fourths, which is 2. 28 minus 16. Time for you, Yasser. 15x plus 10. Oh, I changed the problem to a negative, right? Okay, that's over 4. All right, 28, 13x minus 26, 20. I think I'm good. And if I put a 2 in, I'm not getting that, am I? 14, oh, 10 fifths. Yes, I am too, right there. Yeah, okay. That's fine. It works. Yeah. Yeah, both of those are 2. 2 minus 2 is 0. Okay. You can tell, getting the end of the day, doing a lot of driving today. So I've taken a cube root. So I definitely want to see 54 as 27 times 2. There's a cube root. X to the 5th is x cubed times x squared. Y to the 14th is y to the 7th squared. Or how about I do y to the 14th? Why don't I do y to the 12 times y squared? And z to the 5th, I'll do as z cubed times z squared. Okay, anything that's a multiple of 3, just like 27 is, 3 cubed, any multiple of 3 is a perfect cube. Okay, so those are the situations that are going to come out of this. So the cube root of 3 cubed is 3. The cube root of x cubed is x. The cube root of y to the 12th is y to the 4th. Remember, y to the 4th times y to the 4th times y to the 4th are the 3 sides of a cube. Okay, and the cube root of z to the 3 is z to the 3. So you're going to divide the exponents by 3, and you're going to take out the biggest multiple, divide it by 3, and then you got remainders. What are the remainders? Don't forget to write the 3, otherwise you have a square root. That will be a deduction. That didn't come out. That didn't come out. That didn't come out. And that didn't come out. And that's a simplified version of that. All right, so that's history. That's that. I hope you saw that. All right, now we got a square root. Well, I can see 25 times 10. I see a perfect square in there. I have x to the 1. I've got y to the 1. I need 2, 4, 6, 8, 10. I need something even here. Z to the 5th. Well, that's z to the 4th times z. So what can I take out? 25. 5. Z to the 4th. Z squared times z squared is z to the 4th. That's a perfect square. I've got 10x, y, z. That's a square root. Takes care of that one. There was no problem number 21. I do not know why. All right, I've got something times something equals 0. And just make the something 0. What makes 9 minus 5x? The addition of 9 becomes subtraction. Multiplication by negative 5 becomes division. 9 fifths is one of my answers. Subtraction becomes addition. Multiplication becomes division. 4/3 is an x value, which when used, put 4/3 in here, in here, in here. It's going to come out as 0. Why? Well, let's look at it in this case. 3 times 3/4. Was that what I had? 4/3. 3x. So it was 3x. So my answer was 4/3. Sorry. I think I was doing 3/4. 4/3. Yeah. What happens to the 3's? Cancel. 4 minus 4 is 0. 0 cubed is 0. 0 times anything is 0. Minus 17 over 99. Okay, so now we're going to up our what times what problems to cubics. So x times what gets me x cubed? X plus 5 times what gets me x cubed? I guess it's x squared. Now I have x cubed, yay, but I have 5x squared. And I want 10x squared. So I got 5x squared here. I need to make 5x squared happen here. I'll multiply by 5x. Now I got 5x squared. Now, that takes care of 10x squared. Now I got to get 2x. Well, we always look to the last foiling, right, which is 5 times 5x, which is 25x. And I got to get to 2x. I got to go down 13. I'm sorry, I didn't think that through. I'm at 25x. I got to get to 2x. I got to go down 23. And that's minus 23 times x right there. Well, that's good. That gets me 2. And now I got 5 times minus 23, which is minus 115. And I've got to get to negative 3. So I've got to go up 112. And I'm not going to take the time to put minus 5 through there right now. But if it doesn't come out as 112, I made a mistake. And I'm going to keep moving along because I'm getting tired. Been a long day. I've already been driven 200 miles today, so I'm tired. So I want to see if this is factorable. I'm going to take a 2 out, and I'm going to see 2x squared plus 7x minus 4. And I can see 4 times 2 is 8, which is close to 7. So I'm going to do 2x and x. Then I'm going to put my 4 there because that's 8x. And I want a positive because if I take 1 away, I get 7. And that's factored now. 3x squared minus x equals 10. Well, I want to try to factor that one too, because if I can set it to 0, I got easy answers. And I can see I got a 3x and an x. And I can see 2 times 3 is 6. And 5 are 1 apart, same thing as last time, and I want that one to be negative, that one to be positive, and I'm setting it to 0. I think I got an answer of negative 5/3 and an answer of 2. Yes, there are 2 answers to quadratics. For the past 2 months, we've been solving quadratics, and we keep getting 2 answers. I think there's 2 answers to quadratics, occasionally 1. You know, when does x minus 5 squared equal 0? Well, when you graph that, you get 1 answer. We call it a double root, right? But generally speaking, you're either going to get 2 real answers or 2 imaginary answers when you solve quadratics. All right. Square root, what's this? Well, it's not linear. We don't start it that way and say x plus 9. It's a square root problem. So we start this way. And I don't change the run to the first power. I change the run to the square root, because that's the units that I'm working with. And if I put a negative 9 in, I want minus 2, the same way we would with a linear. Right? But now, no change, negative 2 to 21, I got to go up 23 units. That hasn't changed. Usually we put this a little lower. The question is, what do I get when I put a 5 in? What do you get when you put a 5 in? I'm still hearing people say 14. That's not what you get. When you put a 5 in here, you get the square root of 14. And if that minus 2 doesn't take you to 21, you got a problem. And I don't think that takes you to 21. So let's get rid of the problem. Divide it out. It's gone. Put a 5 in. Gone. 23 minus 2, 21. We're done. Of course, you should say y equals somewhere, I suppose. Okay, so that's that one. I'm seeing cubics. I'm seeing multiples of 3. So I'm going to factor this. That's what I asked for. And what is the cube root of 125x to the 6? We'll divide it by 3 and find out. 5x squared. 27. 3y to the 5. Everything is built off of those 2 numbers when you factor the difference maintain that symbol. Square both numbers. When you square both numbers, you get positives. 25x, oh, I am getting tired. 25x to the fourth, 9y to the 10th. That's squaring, and these are both positive. I don't need to put a plus in front of there. It's understood to be a plus. Then do the multiplication, negative 15, make it positive 15, and you'll get cancellation, x squared, y to the fifth. Now, I've done this out numerous times to show you the cancellation. Not going to do it again. If you want to see 4 terms cancel, multiply it out. You'll get 6 terms, 4 of them will cancel. Binomial squaring. Square the first number. Square the last number. Again, when you square, you get positives. What do we do with the 2? We multiply them, but we don't change the sign like we did in the last problem. And we double that product. So we're still working with what's in the parentheses. Minus 3 becomes minus 6, x, y to the 10th. And that's what you should get if you did parentheses times parentheses. It's just a little shortcut because we work with it so much. In fact, we're working with it again right now. 81. Double that. Minus 63 doubled. Minus 126i. 7i times 7i is 49i squared. What's I squared become? Negative 1. So I'm taking 50 away, 31, and then going up 1. I should be at 32. Oh, wait a minute. 32 and 49. Yeah, I guess so. Yeah. Okay, 32. I'm having a mental block. Minus 126i. All right. I think that's right. Yasser's there to help me. All right. Minus 7i to the 53rd. Minus 7i squared. How many times do I square something to get close to 53? 26. Takes me to 52 times one more I. I have minus 7, negative 1 to an even number times I. Well, if I do negative 1 twice, it's positive. If I do it 3 times, negative, 4 positive, 5 negative, 6 positive. I think that's positive 1. So minus 7i. If you keep doing those, you do them in 3 seconds. All right. Getting there. Let's get this chair out of the way. Come on, Rennie. Stick with me. Don't abandon me now. All right, we've done this quite often. X cubed times 5x minus 1 equals 0. Show it as a product. We have answers. X equals 0. Probably some imaginary roots here too, but we're just looking at these 2 real roots. 0 and 1/5. Okay, we're writing this equation. So x minus 5 squared minus 3. What's my squared change? 5 to 10. My squared change is 25 units. My real change is negative 3 to 11, which is 14. That's that function. We'll write y here. Vertex, y-intercept sketch. Well, we might as well just sketch it. Include the vertex and the y-intercept. Cup shape down. Vertex, minus 12 divided by minus 6. Minus b over 2a. Minus 12 divided by 2 times negative 3. Positive 2 again. I've seen that number before. If I put 2 into the equation, 24 cut in half is 12 minus 5 is 7. You take your time with it. Put 2 in, you should get a 7 out. Y-intercept is to the left of 2. 0 is to the left of 2. Did I mention that 0 is to the left of 2? Negative 5. There's your vertex, there's your y-intercept, there's your sketch. All right, center and radius. So the center is going to be at 4, comma, negative 6. Squaring that, 16 and 36 plus 12. My radius is going to be 48 and 12, 64. 48 and 12 now, it's 60, huh? Boy, I usually like giving you nicer numbers. Yep, 36, 46, 52. No, see, this was 64, so your radius is 8. All right, now let's do the problem out. Completing the cube, x minus 4 squared, cutting that in half. Remember what x minus 8 is, x minus 8. That's a rectangle, that is not a square. The only thing I can work with, the x's are the same. The only thing I can work with is -8. So I'll take half of that, -4, put it over here, -4, and now I have a square. The only thing is, I don't see the number 16 running around here. So I'll get rid of that 16. And now when I do the binomial squaring, the 16s cancel. And I get x squared minus 8x plus y squared plus 12y becomes y plus 6 squared minus 36 for the same reasons, equaling 12. Move the constants over, you got 64. You got x minus 4 squared plus y plus 6 squared, which is a triangle with a side length of x minus 4 and y minus 6 and 8. And as one gets bigger, one area gets bigger, the other's got to get smaller, right? We get this rotation, this circular rotation. So center 4, -6. I hope that's what I wrote before. Radius, square root of 64/8. All right, getting there. You want to shortcut this one? 4 and 49, 53. So I'm going to get 53 there. Provided I do what? Conjugate. 2 minus 7i, 2 plus 7i. 2 plus 7i, I'm multiplying by the number 1. Something divided by itself is 1. It's not going to change the size. You can see what I'm doing, yes. 9 times 2, 18. 9 times 7i, 63i. 4i times 2, 8i. 4i times 7i, 28i squared. That's where people make their mistakes. A lot of people forget to say I squared. Please don't. This becomes -28. Take it away from 18, you get -10. 63 plus 81, 144. I. And if we do this, I hope you can see the middle terms cancel and you get 4 minus 49i squared. You're always going to get a negative. You're always going to get a negative times a positive or a positive times a negative. So that square is always going to be a negative. When you put I squared after it, it becomes a positive. So that's why I was able to say 53 so quickly before. Almost done. So I want to find h of x. Find h of 8/3. Well, I got to put 8/3 into g and do the math. And then I got to get that answer and plug it into f. But I thought it would be more fun to do f of g of x, which is f of what? F of g of x is 2x minus 9. So I'm going to have to put 2x minus 9 into that function, which means I'm multiplying it by -3 times 2x minus 9. And then I'm subtracting 9. And so that gives me -6x plus 27 minus 9 is 18. 6x plus -6x plus 18. All right, so what's the best way to shortcut that? How about we do -6 times x plus 3, -3, excuse me. X minus 3 is another way of writing that. Now I'm going to plug in 8/3. I think that's the easiest way to do it. So now I have 8/3 minus 3, which is 9/3, which is -1/3, and -6 times -1/3 is simply 6 divided by 3. The answer is 2. Lots of ways to do that. The old guy's getting tired. That's the way that I thought I might be able to do it most easily. All right. Don't erase things. Perpendicular to 5x plus 2y equals 29. We've done that enough. I know what the slope of perpendicular is. It's 2/5. If you're not sure, solve it for y. Take the negative reciprocal of the original slope. You'll get 2/5 through CD. X minus c plus d. And that's my new function. It's perpendicular to this one. All right, so guess I'll show you. 2y equals -5x. We don't care about the constant. My original slope is -5/2. What's perpendicular to -5/2? 2/5. Knew it to begin with. Where does -5/2 come as an original? divide by 2 and change the sign, and then you can save yourself all that work. All right, so this time I've got something where I just wanted similar question to what we did before, but I'm hoping you don't multiply by 20. I'm hoping you multiply by 10 so that the numbers are more manageable. So that's 15x minus 30 equals negative 7x plus 10. Now I'm stopping there. If you can do that, you're going to get the problem right. 3 coordinates. Problem number 2 is 3 coordinates of this function. So I can get rid of that now. So I'm looking at 4/7, and I'm starting with a 2, 5. Stay in the column X, change by 7, 9, 16. Stay in the column Y, change by 4. See if 16, 13 works before moving on. 13, I got a problem. Oh, 16. 16 minus 2 is 14. Oh, that's nice. 14 is a multiple of 7. 2 times 4, 8, plus 5, 13. Move on. Now, y equals 4/7 x minus 2 plus 5 in slope intercept. So I can definitely see 4/7 x. That won't matter. What matters is getting the rest of it right, because I'm not giving any points here. Got to know how to multiply fractions and add fractions. So minus 8/7. 5 is 35/7. Final answer, 4/7 x. Take 8 away from 35, 27/7. That's what I'm getting. Last problem, and I'll upload it. You might cut out a careless error now and then by plugging these into tabular form. Okay, minus 8/11, x plus 8 plus 11. We know that. I can see the change in x is 5. I can see the change in y is down 2. That's my function, my y equals. All right, done. Hope I kept the camera centered enough that I didn't lose a problem or two, but could have easily done that tonight. All right. Have a good day. No school here tomorrow. Probably do another lesson set of some kind just for practice over the weekend since you're missing a class. Toodaloo.